Now let us write Verilog code for 421 multiplexer here. Okay, now what I'm going to do, let me use the wire concept only even here. So I'm not drawing the diagram. You may think, hey, without drawing the diagram, how can I use the wire actually? So the simple what I will do, just from this only, I will do something simple, like see, this is our Boolean expression as we know, right? So in this Boolean expression, I will split up the min terms. So what I will do, I will consider this is the one term, this is the another term, this is the one more term, this will be the another term. I will name it this term because already I used S1, S0 and all. I will go for some other term for this. What I will do, let me take as something called as this is P, this is Q, this is R, this is S. Let me take this system. I will consider as wire now. So let me start the coding here now. First module, which one it is? It is a mux 4 to 1 actually. What is the inputs now? Inputs are I1. So it's a 4:1 mux, right? So it is I0, I1, I2, I3. Then selection line S0, S1. Then output is Y. Now next here inputs are I0, I1, I2, I3. Next second I will write simple like this because for your understanding purpose S0, S1. I have splitted the inputs. Even you can write input all the variable in a single line also, but just for your understanding purpose I am written like that. Output is Y. Okay, this is over. What next actually? Now let us go for the wire actually. Let me go for the wire. Yes, wire. What is the wire there? P, correct? P, Q, R, yes, totally 4 wires actually I'm using here. Okay, next let us start with the concept. Let us go for the concept. Yes, assign. First I will write for wire better. Assign P is equal to, what is P actually? See, I naught first, okay? I naught, okay, dot is nothing but under. That is nothing but under. So I naught and next what? S1 bar. So what I will do? Not S1. You may have the doubt here. 10, 1 I0 ampersand not S1. You may think whether the system may get any confusion over that. No, the system will not take any confusion over there because always the system will prefer the highest priority will be given to the not operation first. So it will perform this operation, then only do this AND operation also. Else, if you're having the doubt, you can use a parenthesis here if you're having a doubt. Better you can do like this. And what is it? Not yes, not. This is first. Next, assign Q is equal to, yes, what is Q? I1 and, yes, I1 and S1 bar. So, not of S1. Next, and what is that? Yes, not. So, yes, not. You can write like this. Next, assign R is equal to I2 and S1, S0 bar. So, S1 and S0 bar. So, not S0 bar. Next, assign S is equal S. Because see, you will use S0, S1, S is not used, so you can use S. S is equal to I3 and S, S1, S0. S1 and S0. See, now the wire declaration is over. Next, let us go for the next declaration. That is nothing but what? We'll go for next is assign. Next we'll go for the assign. What we'll do? First assign is what? This P R with Q R with, see, this is a multiplexer, right? If you see the multiplexer, you can see finally what will happen. You will get a single OR gate. Everything will be connected to one single OR gate actually, right? So what I will do finally, I will write assign Y is equal to OR gate of what? P R Q R, that is R is yes. Yes, this is the statement. You can see assign y is equal to, see, this is the statement actually. End the module. See, this is what you have to write like this only. The same the way we can follow for 8:3 also. So once again I say the vector inputs here. How to specify? The vector values will specify as 3 colon 0, because if you are having input more than 1 bit in the sun, we have to use like this. See, the 3 colon 0 I, the 3 represents the MSB position, the 0 represents the LSB position. So how you can represent this value in the sun? 3 colon 0 of I will be written as like this: I of 3, I of 2, I of 1, I of 0. See here, clearly we specify here. So this is the I value is 1011, means if I specify 3 colon gene, this one is nothing but your MSB position. This will be your next position. This will be your 1 position. This will be your LSB. That is 0 position. If it is 0 colon 3, means this will become as 0th position. This will become as 3rd position. Means your MSB number will be remain same, this 1, but the position only is get changes. So very important. Don't write like this and all. Here, see how should not write. I'll say one more thing here. Very important. Should not write. How to should not write? Note. It is like this. I of 3 colon 0. This is not the vector value. This is not the vector form value. See, like this: I of 3 colon 0. You should not use like this. 3 colon 0, then you should follow I. Remember, if I am having multiple input parameters with the same dimensions, then I can use comma like this. The example, I am adding 2, 3 are inputs with length is 4 only. So it is simple: 3 colon 0, P comma Q comma R. If I say the P, Q, R, all the 3 parameter has 4-bit value. So in this way you have to write. I hope this is clear for you. So now next, what you will do? Let's see something about how to write the program for. You may sometimes they may ask, write the program for like write the Verilog code for 4-bit adder using data flow model. Yes, 4-bit adder data flow model. How you will write this now? The first thing is what you need. You should draw the diagram of 4-bit adder, or otherwise I can call it as parallel adder. Parallel adder, or other name is what? Ripple carry adder. Okay, so how you will write now? So simple, you need to know the diagram of yes, see, now this is the diagram for 4-bit ripple carry adder. Now how we will write the program for this? Very simple. Your input will be what? Module. I will write only very simple. Rest of things you carry on. ripple carry adder, I'll say RCA. What are the inputs here? A is the one input, then B is the one input, then C in is the one input, then sum is the output, then finally C out. C out is the output. Now I return like this only, but A is 4-bit, B also is 4-bit. So I'll write here. Input, what is A and B both are 4-bit. So how can I write now? It is 3:0. A comma B. So both has. Next input C in separately you have to write. Why? Because the AB has 4-bit, but your C in has it's a single bit. Next what I will do? Output. Let me go for output. Output is also 4-bit. So it is nothing but 3:0. 3:0 sum. You remember, don't write as 4:0. If I write 4:0, then that will become as 5-bit. Okay. Next output is C out. It is a single value, so it's supposed to be C out like this. Now you check the diagram. Is there any wire? Yes. C, C0, C1, C2. This is the wires actually. Correct? So what I will do here? This is C3 is no. The C3 is nothing but C out normally. You can write as C out or C3 also. Now C0, C1, C2, C3. Here wire also you can write like this. See 3:0 C. You can write like this. C also has 4. C0, C1, C2, C3. Next what you do? You have to write each individually. You have to write first assign. You have to write completely this. How will write this? Very simple. I will write only for this. I will write rest of the things you write. Okay. So assign first for this sum, that is S of 0. Correct? Because see this sum is nothing but S of 0. Why? Because this is a 1-bit adder actually. So I will write as like this. Sum of, because here I declare as sum actually. I am not declare as yes. If you want to declare as yes, even you can declare as yes also. No problem. As per that, if you want to go, let us do in this way. No problem. Yes. So let me do in this way only. Yes. So now S of 0 first. What is S of 0 actually? Sum of 0 in full adder. You remember what is the sum expression? A XOR B XOR C. So simple. A of 0 XOR B of 0 XOR C in, because already said C in. Correct. Next comma I will write carry is there, right? What is that C0? C0 is nothing but your wire. So C0. C of 0. What is C of 0? It is a carry out expression. What's a carry out expression of 1-bit adder? It is AB. So A of 0 B, right? That is and. I will put one bracket here. Yes. B of 0. Yes. B of 0. B of 0. AB. Correct. AB. Next. A dot B. R. Pipe symbol. Next. BC. So B of 0 and C in. That is C in. Correct. That is C in. Close the bracket. Next again OR gate. OR gate again open the bracket. AB, BC, CA. It is nothing but CA is nothing but what? CS input. C in and A is A of 0. See, this is what first, this is simple. I can say this one is for FA1. See, I will say this is FA1. So this is FA1. Next, write for FA2. Same. Assign. Input will be what? A, B, C 0. C of 0 is the input. Output is S1 and C1. That is S of 1. C of 1 is nothing but your output. Someone carry. Next, same the way. Next Next, finally, what you do, output the C out, because here we given C out, right? This C out, assigned C out is equal to C of 3. So this will be your homework, complete and upload in a Google Classroom. This one, yes. Take about this as a assignment. Assignment 4-bit adder using data flow model. Very important. Don't miss anything. So if you miss, so very difficult examination to study this. If you face any problem with Verilog HDL, be free. You can ask in the Google class, or you can ask anytime. You can ask. Simply don't be yourself. Yes.